triangles and special quadrilaterals. Now, this first chapter, we did some introduction stuff. The rest of the chapter is just like a little bit of a snapshot of chapters down the road. So we're going to talk a little bit today about triangles and a little bit about special quadrilaterals. But we have like 2 chapters just on triangles. We have a whole chapter just on special quadrilaterals. Okay, so we'll get more in depth. This is just kind of an introduction to those shapes. All right, so as we start talking about figures, there's a couple of things that we need to talk about what you can assume and what you cannot assume. Okay, what we can assume just looking at a figure is that we have vertical angles, meaning we have 2 lines that intersect. Okay, and we can assume that angles 1 and 2 are vertical. That's okay. We can assume that angles are adjacent. So we can assume that angle 1 and 3 are next to each other. There's not another ray that's really close you just can't see. Okay, we're not trying to pull a trick on you like that. And then you can also assume adjacent supplementary angles. What's a better name for adjacent angles that are supplementary? A linear pair. This is the same thing as a linear pair. Okay, so that you can assume if they form a line, they're a linear pair. Okay, what we cannot assume unless the figure is marked is we cannot assume that angles or segments are congruent. We talked about that last week and a little bit the week before. We cannot assume that an angle is a right angle unless it's marked that way. We cannot assume that lines are parallel or perpendicular, again, unless they're marked that way. Okay, so just because lines look parallel doesn't mean we need to say they are. Questions about any of that? All right, so we're quickly going to talk about triangles, and honestly, all of this should be familiar to you. So if I'm going too fast, tell me to stop. I want to keep this moving. So we can classify triangles by angles. If we have 3 angles that are acute, it's an acute triangle. If we have 1 obtuse angle, it's an obtuse triangle. If we have 1 right angle, it's a right triangle. If all angles are the same, then we learned this term equiangular last week. It's called an equiangular triangle. They actually all happen to be 60 degrees. While we're talking about this, is it possible to have more than 1 obtuse angle in a triangle? Good answer. So think about that. If I had an obtuse angle that looks like this, it's obtuse, right? I don't know the measurement, but that's okay. And what if I created another obtuse angle over here? Would those 3 sides ever be able to meet? No. So that's why you can't have more than 1 obtuse angle. Same thing with the right triangle. Okay, you can't have more than 1 right angle. Questions on any of that? All right. The next one is classifying by sides. So if no sides are congruent, it's called scalene. I want you to underline for isosceles at least 2. So if you have at least 2 congruent sides, if you have at least 2 congruent sides, then it's called an isosceles triangle. Okay, we're going to talk about why that's important in a second. And then if all 3 sides are congruent, it's called equilateral. Again, that term came up last, right, when we were talking about polygons. So isosceles says at least 2 sides are congruent. Could be more, but you have to have at least 2. So this leads to a good, always, sometimes, never question. Okay, so not just true or false, but is it always true, sometimes true, or never true? So let's look at the first one. An isosceles triangle is an equilateral triangle. The second statement says an equilateral triangle is an isosceles triangle. I'm going to give you about 1 minute here to talk about it with your table, both of those. What is that? Yeah. It would be something. Okay, 10 seconds. But you wrote it so much smaller, so it's like you had like your own arm.
No, like maybe it was.
Really? Oh, that's so cool. All right. So what do we think? Let's start with the top one. An isosceles triangle is an equilateral triangle. Sometimes I hear that. Yeah. I hear some sometimes. You may disagree. So an isosceles triangle we know has at least two congruent sides, right? An equilateral has three congruent sides. If I do that, is it still isosceles? Yes, because it has at least two congruent sides. Does it have to have three though? Is this still isosceles? Yes. So I could have an isosceles that looks like this, like triangle number 1, and I can have an isosceles that looks like triangle number 2, right? Are both of those equilateral? No. So this is a sometimes. Sometimes an isosceles triangle will have a third side that's congruent. Sometimes an isosceles triangle won't have a third side that's congruent. Does that make sense? Okay, how about the last one then? An equilateral triangle is an isosceles triangle. This is an always. Because here's my equilateral triangle. Think about your definition of an isosceles triangle. Does it have at least two congruent sides? Yeah, it'll always have that because we always have three. So this is an always. All right. Questions about triangles? Questions about triangles? All right. Next what we're going to do is we're going to look at all of our quadrilaterals. Okay, we're going to look at all of our quadrilaterals. We're going to start with the trapezoid. Okay, so up here I have examples for you of all different types of or a couple different types of trapezoids. So a trapezoid is a quadrilateral with exactly one set of parallel lines. That word exactly here is pretty important. So exactly one set of parallel lines. So exactly one set of parallel lines. So the top two are typically ones that they'll show kids for like shape recognition. Like when they're starting to introduce shapes to you, that make them look the pretty ones. Remember how we talked about that the other day with regular polygons? Okay. For trapezoids, they call these isosceles trapezoids. What's really happening is here the non-parallel sides are congruent. Okay. These are called isosceles trapezoids. They're called isosceles trapezoids. But this bottom one is just a plain old trapezoid. The legs are not congruent. The non-parallel sides are not congruent. Again, you typically see the isosceles when you're just trying to identify shapes. Questions about trapezoids? The next shape might be new to you in terms of being a geometric shape. So the next shape is called a kite. Okay, so it looks like let's go fly a kite a lot of times. So it's a quadrilateral with two distinct pairs of consecutive congruent sides. So two distinct pairs of consecutive congruent sides. I'll give you a second to write that down, and we'll talk about what that means. All right, so two distinct pairs of consecutive congruent sides. So let's start with consecutive congruent sides. That means we have two sides in a row that are congruent. Okay, when it says distinct pairs, it means that all four sides cannot be the same measurements. We need two sets of measurements, and the sides that are congruent need to be next to each other. Does that make sense? All right. The next shape are parallelograms. So parallelograms, by definition, is a quadrilateral with two pairs of parallel sides. So just two pairs of parallel sides is what makes a parallelogram a parallelogram. Now the bad thing is you're a little bit dangerous right now because you probably know other things about parallelograms, but those are called properties of parallelograms. And those properties happen because you have two sets of parallel lines. And we're going to talk about all those properties, but you need to understand what makes a parallelogram a parallelogram. It's just that it has two sets of parallel sides. Okay? Questions about parallelograms? I'm going to dump a bunch of shapes into it, and we're going to kind of put it together, okay? Next shape is a rhombus. So a rhombus is an equilateral parallelogram. Or you can say a rhombus is a parallelogram with four congruent sides. However you would like to write it, it's fine. So it's a parallelogram with four congruent sides. Our next shape is a rectangle. So a rectangle is a parallelogram again, but now it has four congruent angles. Or you could say it's equiangular. Parallelogram with four congruent angles. All right, finally, can I change this? Okay. Finally, we have a square. So a square, you can think about it a lot of different ways, but it's a regular quadrilateral, meaning has all congruent sides and all congruent angles. Okay, so it's a parallelogram. It has four congruent sides, four congruent angles. So I tried to write this a couple different ways just to use that equilateral and equiangular term, but you just need to know that it has four congruent sides, four congruent angles. All right, so I just threw a bunch of shapes at you with a bunch of definitions. So I want to put it together and show you how they're all interrelated, or not. Okay, so we're going to talk about what's called a quadrilateral family tree. So we have quadrilaterals. Quadrilaterals, any shape with four sides, right? Any polygon with four sides is called a quadrilateral. Now, we have a lot of different quadrilaterals, and sometimes they have some special properties. Sometimes we have some kites, meaning it has four sides, but it has two distinct pairs of consecutive congruent sides. Those are no parallel lines. We never talked about parallel lines with those, right? We said two sets of consecutive congruent sides. Then we said, well, if we have one set of parallel lines, those are called trapezoids. So if we have a four-sided figure with only one set of parallel lines, those are called trapezoids. And we had some that were a little bit more recognizable because they're called isosceles trapezoids. Right? They're trapezoids, but they have an extra special piece that the non-parallel sides are congruent. Then finally we said sometimes we have some quadrilaterals with two sets of parallel sides, and those are called parallelograms. So if we have two sets of parallel lines, those are called parallelograms. And we had some special parallelograms as well. We said if it had four congruent sides, it was called a rhombus. We said if we had a parallelogram with four congruent angles, it was called a rectangle. And if we marry together the four congruent sides of the rhombus and the four congruent angles of the rectangle, it would make a square. Okay, so this is kind of a big picture of how they're all interrelated. And if you can understand this flow chart, it makes always, sometimes, never questions pretty easy to answer. Okay, so we're going to think about some always, sometimes, never questions. So let's think about the parallel lines. How many sets of parallel lines does a kite have? 0, right? How many sets of parallel lines does a parallelogram have? 2 sets, right? So can a figure have both 0 sets of parallel lines and 2 sets of parallel lines at the same time? No. We can never jump from branch to branch on the family tree. And we can't jump from kites to trapezoids, or trapezoids to parallelograms, or parallelograms to kites. Okay, we can't jump those branches. All right, as we move down our family tree, we become more and more and more specific, right? If I move up my family tree, I become less specific. So let's think about a square. Is a square always a quadrilateral? Is a quadrilateral always a square? No, because I can think of lots of quadrilaterals that are not square, right? Sometimes we can be more specific and travel down the family tree. Sometimes a trapezoid is an isosceles trapezoid, but not always. Right? Sometimes a quadrilateral is a rhombus, but not always. But can I always be less specific? Yes. So I can always go up the family tree and be less specific. All right, so I'm going to shout out 2 shapes, and you're going to tell me always, sometimes, never. Okay, you're just going to yell it out. So how about a kite is a quadrilateral? Always. Always. Good. How about a parallelogram is an isosceles trapezoid? Never. Never. How about a rhombus is a quadrilateral? Always. A rhombus is a quadrilateral. We're being less specific, so that's always. How about a parallelogram is a rectangle? Sometimes. How about a trapezoid is an isosceles trapezoid? Sometimes. How about a rectangle is a kite? Never. Does that make sense? If you can follow the rules and then understand the relationship. Okay, so your homework is out of your book. So if you don't have it, take a picture of someone else's, or you can go get it. It seems like a lot because at 20, but it's like matching right in the beginning. There's a lot of matching, so it goes fairly quickly. Okay, in fact, I think you could probably get it done before we get it.